Welcome back again, solving numerical problems from parallel forces and couples. Problem set 3.1, solution to 3.1b. 3.1a is already discussed. Before you solve this problem, try to understand, go through my previous video in which I have explained solution to 3.1a. and I have explained the Briggson's principle of like parallel forces. Now the statement of the problem is like this. Resolve the same force 4000 Newton as it was given in 3.1a, shown in the figure here also, into parallel components P and Q acting respectively, but not along the same direction, along BB and CC. Now look, so the original diagram I have redrawn once again for you here. Now if you look at this line is CC, this line is BB. From the point A 4000 Newton is acting to this side, and since we have to split this 4000 Newton to two parallel components P and Q, and P will be acting through CC dash, through CC, and Q should be acting at BB, along BB. So what is the conclusion? The system is unlike parallel forces because the resultant R is lying outside P and Q, as can be visible from the diagram just given below. So this point is a same thing as A. 4000 Newton is acting to this side. Along CC dash, we have to take the force P, and along BB to this direction, I have to take the force Q. I have to take it in this direction because this 4000 Newton, which is acting from point A, is not between P and Q. It is not in this interval. So the Q and P have to be in opposite directions. Since P and Q are in opposite directions, the angle between them is 180 degrees. And from parallelogram law of vector addition, we know R square is P square plus Q square plus 2PQ cos theta. Since P and Q will be acting in opposite directions because R is not in between P and Q, therefore cos theta is 180 degree, cos 180 is minus 1, so this becomes P square plus Q square minus 2PQ. This right hand side becomes whole square of P minus Q. By taking square root, R becomes P minus Q, right? And from here to here is 1 unit, and from here to here is 1 unit, and from here to here is 1, 2, 3 units. So that is what I have shown here. From here to here is 1 unit, and from here to here is 3 units. And therefore P times 1 will have a turning effect about the point A, that is clockwise, and Q times this from here to here 3 units will have a turning effect anticlockwise. And since in the last video I just explained the Briggson's principle, let me read it out again for you. The moment of R about point C is equal to the algebraic sum of the moments of P and Q about the same point. That was the principle. So the moment of this 4000 Newton about point A is 0 because the line of action of this 4,000 Newton from this point does not have a perpendicular distance. So the effect of the turning effect of this 4,000 Newton about point A is 0. Now, and P is acting to this side. So P times this perpendicular distance has a turning effect about A, that is clockwise. And how much will be that? P times 1. And since Q is acting along BB, so to balance this, P times 1, that is a clockwise turning effect, it has to be balanced by an anti-clockwise turning effect. So Q has to be this way. So Q times from here to here is 3 units. So P times 1 is Q times 3. Then only the algebraic sum of this moment and this moment will be equal to the moment of the force 4,000 Newton about point A. Now from here, R is given as 4,000 Newton is P minus Q. So from here I get Q as P minus 4,000 Newton. So apply it here. So P times the perpendicular distance is equal to Q, that is P minus 4,000 times the perpendicular distance. So P into 1P is 3 times P, 12,000. 3, this comes to this side, 12,000 comes to this side. So we have 2P is 12,000. So P is 6,000 Newton. And then put this value here to get Q as 2,000 Newton. So that is all about. So thank you for watching.